All right, welcome, hello and welcome. Today we are going to be looking at question number 2 on shear stress and strain. Of course, we are still under machine design. The question says a pull of 80 kilonewton is transmitted from a bar X to the bar Y. Of course, you can see where we have X and where we have Y here. A pull of 80 kilonewton is transmitted from bar X to bar Y through a pin as shown below. Now this is the pin. Now if the maximum permissible tensile stress in the bar is 100 Newton per millimeter square and the permissible shear stress in the pin is 80 Newton per millimeter square, find the diameter of the bars and of the pin. Find the diameter of the bars and of the pin. So what? We are going to be bringing out our data here. So we say solution. So data is given. So what do we have first? We have a pull of 80 kilonewton. So our P is equals to 80 kilonewton, which is equals to 80 times 10 to the power of 3 Newton. What do we have next? We have a maximum permissible tensile stress of 100 Newton per millimeter square. So we have a tensile stress of what? 100 Newton per millimeter square. Now, we also have a permissible shear stress of 80 Newton per millimeter square. We have a shear stress of 80 Newton per millimeter square. And lastly, okay, that will be all. So we are asked to find the diameter of the bars and of the pin. We have to find the diameter of the bars and of the pin. So the first thing we are going to be doing is we are going to be finding the diameter of the bar. So we can say number 1, diameter of the bar. Now, in order to find the diameter of the bar, we are going to be looking for the area. We are going to be using the formula of area. And of course, area, we can denote it as A subscript B, that is area of the bar, will be equal to what? Pi by 4d square. Now, we are not given diameter. We are not given diameter. So, of course, from here, we can say that A subscript B is equals to pi by 4 is nothing but what? 0.7854. So we have 0.7854 d square. So this will be our area for now. So next, what do? We have a load of 80 kilonewton. We also have a tensile stress of 100 Newton per millimeter square. So we are going to be using the formula that says sigma T, sigma, that is our tensile stress, is equal to what? Is equals to force all over what? All over area. But in this case, we are considering the area of the bar. So we have A subscript B here. So our tensile stress is nothing but what? 100 Newton per millimeter square. So we have 100 Newton per millimeter square, which is equal to what? We have our load to be 80 times 10 to the power of 3. So we have 80 times 10 to the power of 3. And our area is nothing but what? 0.7854. 0.7854 d square. So this is what we have. So of course, from here we can make d the subject of the formula, and then we have gotten our what? Our diameter for this bar here. So how do we do it? We can simplify by cross multiplying. So we have 100 multiplied by 0.7854 d square to be equal to what? This will be equal to 80 times 10 to the power of 3. So this is what we have. So next, of course, we can divide both sides by the coefficient of d square. Having 100 times 0.7854, we have 100 times 0.7854. So of course, this we go with this, and lastly, we are going to be left with d square to be equal to 80 times 10 to the power of 3 all over 100 times 0.7854. Of course, from this point, we can take the square root of both sides and we are going to have our value of d. So we can square both sides. Square root will go with square here, and we can also square this side. Now if you simplify this by what? By dividing and taking the square root, you realize that our d, that is our diameter of the bar, will be nothing but what? 32 millimeter. So I'm going to be wiping this place. Of course, if you simplify that, you're going to have equal to what? Will be equal to 32 millimeter. Of course, what we just looked for is the diameter of the bar, so we can put a subscript here to indicate that. So we have d subscript b here, d subscript b here. I think that's all. This subscript b here. So next, we are going to be looking for the diameter of the pin. That is this pin here. We are going to be looking for the diameter of the pin. So number 2, we have what? Diameter of the pin. Now, in order to get the diameter of the pin, we are going to be looking for what? The area. First, we are going to be looking for the area of this pin. How do we do that? First thing first, if you look at this diagram here, we have a load of 80 kilonewton and a tensile load of 80 kilonewton. This tensile load tends to make this pin shear off. So what we are going to be doing is this. For the area of this pin, it is going to be A subscript P will be equal to what? 2 pi all over 4 d square. Now we are having 2 here because this pin is shearing off at two directions. So we are having a shear here and also a shear here. So this pin is shearing off at 2 directions. So the area is going to be 2 pi all over 4 d square. So this is what we have. So of course we know that 2 will go here and 2 will go here, but we're left with 2 here. So AP will be equal to pi by 4, pi by 2 rather, d square. So this is what we have. So we can substitute and we will get our area of the pin. So if we do that, the area of the pin will be nothing but pin is equal to what? Pi divided by 2 is nothing but 1.571. So we have 1.571 d square. So this is our area. Next, we are going to be, of course, we are looking for the diameter. So we are going to be using the formula for shear stress. We are going to be using the formula for shear stress because we were given the shear stress of the pin to be 80 Newton per millimeter square. So and we know that shear stress is nothing but what? Is nothing but our force all over what? All over area. And we have our force here to be nothing but 80 kilonewton. So this will be 80 equal to what? Equal to 80 kilonewton, which is 80 times 10 to the power of 3 all over our area, which is 1.571 d square. So of course you can just cross multiply and then you have your d subscript p, that is the diameter of the pin, to be equals to what? 25.2 millimeter. I think that is all for this question. So we have calculated what? The diameter of the bar and the diameter of the pin. So thank you for watching. Be sure to subscribe, like, and if you have any comment on what we just did here, you can drop it and you'll be replied as soon as possible. Thank you for watching.